Here we're going to take a look at how to calculate the percentages of scores above a raw or a z-score. It's fairly simple and we can do it in 5 steps, well, more or less 4.5. Let's start out by setting this up. Let's use an IQ score. Let's say that we have an IQ score equal to 110. So our raw score is 110. We know based on how IQ tests are set up that the mean score is always 100. And we also know that the standard deviation is also equal to 16. Those are 3 things that we know based on IQ tests, and we can use those to get started on finding out what percentage of scores are above 110 in terms of IQ scores. So let's look at step number 1. Step number 1 is to convert our raw score into a z-score. We can do that with our formula z equals x minus m divided by standard deviation, or SD. What's nice is that all this information is given to us from above. We can just plug in all these numbers into the formula and we get something that looks like 110 minus let's actually plug it in this time. 110 minus 100 divided by standard deviation of 16. We can do the math. We can do 110 minus 100 equals 10 divided by 16. And 10 divided by 16 calculates out to 0.625. We now have a z-score. 2. And also 3 at the same time. We're going to draw a curve whatever, lousy curve, so what? And we're going to put on the z-score breakdowns, and we know that the z-scores are broken down in this way. If we have a z-score equal to 0.625, then we can roughly estimate that our z-score is going to lay somewhere along that line or so. And also based on what we learned about the normal curve, we know that this lies somewhere between 34% and 14% of the total people, or of the number of people who could have scored on this IQ test. So we're going to use that as a reference range to find out if we were close to figuring out exactly where we should be. It's more or less a check just to make sure that you fell within the right area when you find your results. Number 4. We are going to look at our normal curve table, and I'm going to trust that you are looking at your normal curve table right now, and I'll give you just a second to find it. Okay, good. So what we can do is we can look at our normal curve table, and we can look down the column that says Z on it, and we can look for a z-score close to ours. And in this case, we're just going to use 0.62, I think is what I used. And if we use a z-score equal to 0.62, we can look down, or look across to the column that says percentage in tail. If we do that, we find that the percentage in the tail, that is, the percentage of people from this dotted line to the right, which is what we're interested in finding out, equals 26.76. So what that means is that 26.76% of all people scored above ours. You know, it's nothing to sneeze at, but you're still within 2 standard deviations, so you're not a genius yet, but you're still better than average. So number 5, to step 5, what we can do is we can actually check and see if we were close or not. what we can do is we can take our percentage and say, is our percentage that we found 26.76% between 34 and 14%. And if it is, which it is in our case, then we can rest assured that we got the right answer or very close to it. That is how you find the percentage of scores above a raw or a z-score. A couple of things to note. If we wanted to know the percentage of scores below ours, what we could have done was subtracted our percentage, which is 26.76, from 100 and gotten 73.24%, and we could have found out how many people scored below us. It's a fairly easy thing to do. What we're going to do now is we're going to change a few numbers around and go through the same formula to find out the percentage above a score that happens to be less than the mean or negative standard deviations. So let's go ahead and let me get that set up real quick. So I have erased some of the other steps. What I'm going to do is I'm going to just modify a couple numbers here. Let's say instead of getting a raw score of 110, we got a 92 on our IQ test. Wake up, pen. Let's say we got a 92 on our IQ test. So let's go ahead and go to step number 1 real quick. We're going to convert our raw score 92 to a z-score the same way we did last time. 92 minus 110 divided by 16 equals negative 18 divided by 16. And negative 18 divided by 16 equals, where's my pen? Hello, pen. There we are. Equals negative 1.125. And we'll call it negative 1.12 when we look at it in the normal curve table, because the normal curve table only goes up through 2 decimal spots. All right, number 2 and 3. Steps 2 and 3 are a little trickier with this because we have to do an extra step. So let's draw our curve. Hey, that looks like something. And we know that this is 0 standard deviations, and we'll go this way and give it 1 and 2. And then the other way we'll give it negative 1, negative 2. We know that our z-score is negative 1.125, so we will give it a dotted line at negative 1, and then a little more for the 125. Okay, so what we're interested in finding is the percentage of scores all the way up here. We want to know how many people scored above us. And we can't just look in the percentage to tail, because that would actually give us the information this way. And we don't want that. We want everything the other way. So we have to, we still rely on a normal curve table, but in order to estimate where we're going to be, we have to go back to what we know about the normal curve and how how z-scores are distributed. We know at this point that 14% are lower, and then 34%, and then the other side is 34%, and then 14%. We know that from what we learned about the normal curve. So what we can estimate is that our score is somewhere between 50%, which is everything to the right of the mean, plus 34. So we know that at this point, 84% of all scores are above where we are. But we also know that we aren't quite to -2, so if we add 14 to our 84, we get a 98%. So we know that our score falls somewhere between 98% and 84%. We know it, we know it. We just have to figure out where exactly it falls in that area. So let's go ahead and take a look at a normal curve table. If we look at the normal curve table, we find that for a z-score of -1.12, but remember the z-table doesn't go negative, so you just use the same value for, you just use the same value but use it for positive. And we want to find, for a z-score of +112, we want to find the percentage to the mean, and then we will add 50, because it's what the normal curve table will tell us is what the percentage is from our dotted line back to the mean. So that will tell us what percentage is in this chunk, but we also know that we have to add 50 more percent to account for the whole right side of the curve. So if we plug in what we know that the percentage to the mean from looking at the normal curve table is 38.88%. Plus 50 equals 88.88%. So we know all scores, or excuse me, the scores that are above us account for 88% of the normal curve, or we can also say that 88% of all scores are above ours, which isn't so hot, but that's okay. Step number 5, I'm going to scroll down just a shade to see what step number 5 will tell us. Step number 5 wants us to check to see if we got the right answer. So what we need to do is we need to, of course, I need to scroll up a little bit more. We need to see if, nope, it's right there. We need to see if our region here is true for where our actual score was. Our score was 88.8%, and that is between our checkpoint of 98% and 84%. So we can rest assured that we got the right answer.